Hi, this is going to be a quick video where I sort of revisit the app that I was working on a while ago, but haven't made any content on it. But I thought I'd show a quick comparison between code generated from two open source models. So let's dive into it. And just for quick context, this is an app that I am building to explore the use of large language models with databases. So database is kind of an interesting use case. A lot of the data that is used around the world in organizations is structured and it's in databases and it's relational. So it makes for an interesting use case whether you can ask a question in just plain English and whether LLMs are smart enough to understand that and then uh, structure the queries to go and fetch the data and then answer the user's question. So here what I'm going to do is I'm going to point to a SQL data source. I'm just going to point it to my local SQL database here. I could specify what uh, 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 databases to look at. So this is my local server, has a bunch of databases, but I'm not going to do that. I'm just going to ask the question, and hopefully the LLM is smart enough to identify the right database, the right tables, and answer the question. Okay. So here it's showing me it's connected to my server, and I'm going to be, the first example is going to be this open source database LLM model called meta-llama. And I'm going to ask a question. Give me a bar plot for the total sales by album by U2. All right, so I'm going to ask it the question and it's going to think for a bit. And this is actually quite fast in terms of response generation. So in the background, it's using a provider called Grok, which is pretty fast inference, and it produces the SQL query and the, the code to sort of generate the plot. Okay, so let's run the code, see if it works. And no, it gives us an error. It says there's an invalid column name. So I'm going to ask it to retry, kind of give it another go, kind of think about it and give me see if it can correct the code. Run the code. Okay, so this time it produced the plot. So it was able to correct itself on the retry and produce a plot. Now the plot doesn't look so great. It's kind of squished. I can see the album names. It's doing the thing I wanted it to do, but visually it's not very appealing. Okay, so I'm going to clear this chat. Now what I'm going to go do is go here and select deepseek. Okay, I'm going to go back to the talk page and ask it the question once more. It's going to think for a while. It's actually going to think for a while longer, so I'm going to talk while it thinks. But the difference between the two is that DeepSeek is well, it's a better model. So it's more of a what's called a GPT-4 class model. It's a bit larger model. It's more efficient. It also thinks a little bit, so it takes time to kind of formulate the response to make sure that the code is good. It's trying to do a better job at understanding the user's question. And I'll talk more in another video about what understanding means in this context. But the other point I wanted to mention is that there's some chatter that I'm seeing that, oh, DeepSeek, when you're using it, you're sending data outside the country. Well, that's not true because this is an open source model. A lot of these models are actually hosted in the US now. So they've kind of downloaded the models, and US providers are serving these models now. So this particular call that was made for DeepSeek is kind of going to US based providers. In this case, it's a company called Deep Infra. It's a company in Palo Alto, California. So that's where it's going and then returning the response. Okay, so here's generated the code. Let's see if we can get a better, well, first of all, does the code execute on the first try? And if it does, do we get a better plot? So the code did execute on the first try and we get a better plot. So it was able to understand the user question. It's able to understand that, oh, I need to, for example, slope these long album names, 45 degrees, so that we can see the plot better. So it's sort of visually more appealing. So it's a very quick example. It's a small example. I just wanted to kind of uh, showcase this to say that, oh, there is a little bit of difference in quality between open source models, but it's an exciting development, because if open source models get better and approach the the state of the art models, then um, one of the visions that one of the explorations that I'm doing with this app is it possible to locally talk to data? So if data is sensitive, that you don't have to even make an API call, that you can just host the model locally, and then be able to connect that to your databases and ask questions. So in this case, both these models are open source. So theoretically, I'm using a laptop here, which is not powerful enough to host it, but theoretically, you could host it on local GPUs, and it'll work just exactly like this. Um, so yeah, so pretty interesting developments here with DeepSeek and in the open source community, and hopefully this uh, kickstarts uh, model improvements and sort of the next cycle of these models. If you have any comments or things that you'd want to explore, especially with the capability of these models with databases, do comment below this and let me know. Thank you for watching, and I'll see you in the next one.